So, we have learned about interface in last two modules, and this is the plan for this module plans for a quick demonstration of the different concepts that we have learnt in our lecture session. So, in today's demonstrations mainly we have planned that how user can create an interface and then maintain it in their package. And interface, as we have discussed, that it follows certain specific properties. So, if all those properties are not satisfied, then whether the interface creation will be successful or not, that we will learn it. And then interface is mainly used for inheritance purpose, more specifically it is a multiple inheritance. So, single inheritance as well as multiple inheritance using interface will be discussed. And another great application of the interface is to provide a dynamic binding in the form of runtime polymorphism. So, that will be discussed. And then we have also mentioned that abstract class and the interface has many similarities between the two. So, what is the difference between the two? So, in our last demo that we will try to clarify further. So, let us have the demonstration first. This is regarding how we can create an interface. So, this is the first program that you can think about how an interface can be created. So, we have to first create a package where we have to store the interface. This is the name of the package, my interface. We have created a subdirectory named the my interface, where the interface will be stored there. So, let us go to the subdirectory my interface, and as we see there is one program. You can just open the program. Yeah. So, this program, yes. So, this is the one program that we have developed. Just this program, as we see, the package statement includes that this my interface is in the package name my interface, and then the name of the interface as we have mentioned here with the keyword interface. The name of interface is an interface, and in this interface we include two elements, A as the member type integer, and then the method display of return type void. And as we see, the member elements that we have discussed here, we do not have mentioned explicitly, but as we know in case of interface the member elements should be public, static as well as final. Anyway, so these are the default. Explicitly you do not have to mention, implicitly also if you do not mention anything in an interface, if it is declared, they will be treated as a public, final, static. And the method, as we have mentioned here, the method should be public and abstract. So, we do not have to mention it explicitly again. If you do it it is good. If you do not do also, the Java compiler will take care about it. So, this is the interface that we have created, and we store this interface in the package my interface. Now, let us see the application of this interface in our program. So, for this we can write one program here. As you know, an interface can be used. If we want to use this interface, then a class should implement it. So, this is the first the class declaration. The name of the class is demonstration underscore 91 implements the an interface which is in the package my interface. We have to import this, of course. So, this is the import statement as we see in the code at the top. Now, so this the method in this class demonstration has the implementation of display, because in interface the method display is there. So, we just implement the code, the display here. So, the code includes a simple print statement fine, and as we do not have to do anything the member element. So, no issue it is here, and in this method, the main method, as we see, we create an object of the class demonstration underscore 91, and then we call the method display is basically interface method, it is here. And also in the last statement you can note it is basically the print statement in the main method, but it can access the member elements which is already there in the interface method A. So, this is the this way this program completes with use an interface, and let us run this program. Here in this case main program is demonstration underscore 91. So, if we run it, so if we run it, we will see exactly how it works. Okay, so the program is compiled successfully. So this program runs it, right. One thing you can see, whenever we create an interface, a class file also should be stored there. As we see in the my interface, both the interface in the form of .java file as well as the .class file is also stored there. So, it is the customary, as we know the process of package creation, the both .java file as well as the class file should be there. Now, so in the interface, as we see that the keywords public, then final, static for a method is not necessary. So, if you put it, that will work fine, no problem, but if you do not put it also it will work of its own, no problem. Now, our next let us have the next demonstration after knowing how an interface can be created and then how the same interface can be used in the program. So, our next the illustration that whether we can create any object of the interface type. Now, so this illustration will give you an idea about, let us consider an interface. Let us consider interface C here. So, this is the interface, okay, built it here, it can be stored in any subdirectory in the same directory. So, this is the interface. Now, our objective is to, if we attempt to create an object of this interface, so what will happen? Now, let us see the program that we can write it, a class program maybe, and then we want to create an object of this. So, let us have the class program here. So, this is the class program, the class file, name of the file is demonstration underscore 92, and here we see the main method. The main method is basically, in the main method we try to create objects of the type interface. There are many ways we can create. So, in the first statement, as we see, the C is the interface type and small c is an object name, new C. Here we want to create an object of the interface C. As we told you, as interface is an abstract, so no object can be created. So, definitely this will leads to an error, and then so and the last two statement we can make it comment. Okay. So, we will discuss about the last two. Now, let us see if we do it, whether we can do it or not. Now, as we see, here is a compilation error in the statement where we have attempted to create an object of interface C. So, it is not possible. So, now let us again revise the program, so that we can comment this statement, and then now other two statement let us see. Now, others two uncomment it, so other two statement uncomment, Now, here again. So, here C is the interface type and we create an object C2, this is quite okay. Here basically we, so there are two difference between the first statement and then this second statement. Second statement is basically create an object and instantiation by calling the constructor, but here we just simply declare an object C2 of C type. So, this is quite possible, we are declaring only, but not creating any object, no instantiation is involved. In our second case also, we can declare an array of type C through array of interface object, but not any instantiation. So, what we can say is that instantiation of any interface type is not possible, however, declaration of interface object is possible. So, in that sense the last two statement is correct. Now, let us see if we run it. So, this program runs successfully, this means that we can create it. Now, we will see the usage of this kind of declaration in our next example, where we will discuss it, not now, okay, in due time. Now, so we have discussed about interface, how an interface can be created, and then how the same interface can be used in our class program. Now, as we have told that an interface should be implemented, and in the process of implementation all the methods which are there in an interface should be implemented successfully. If we do not implement any method, or if we implement one method as a private or something other type, then it should give an error. So, now let us have the complete program here. Here in this code we see the first few declaration about interface I1. In this interface we declare one field called Pi and declare a public static final, that is okay. Also we declare another member elements lambda, the floating type. Now, so this is fine, and then also in this method, in this interface we declare one public abstract method by default, namely the void method 2, method I2 here. Okay, so all these things are perfectly okay, it will work because it is as per the specification of the interface declaration. Now, as we know, in case of interface only the member that will be declared as a static, no instance variable is not possible. Now, let us see if we want to declare a variable say x of type integer and it is declared as a 100. So, this basically considered as a instance variable. So, this leads to an error. If we run this program, okay, fine, we will run it later on. Let us have few more discussion about it here. Now, here class A1, class A1 implements I1, and this is a simple implementation where we have the class A itself its own member A1, and then method 1 its own, and then method 2 is an implementation of the interface method. And as you see, as the class A implements I1, all the elements those are there in interface is readily accessible to this class A. For example, Pi, this is accessible via the method of its own, method I1. And now, the main class, as we see in the main class here we just create an object of class A1, and then all the methods which basically implements the A1 including the class A1 own method is invoked here. So, this will run successfully, but before running this program, that definitely we should comment the int x, comment int x, yeah, int x should be commented here, no, next one, yeah. Now, okay, fine. So, this program compilable as well executable. So, let us quickly compile it, and then we will come back to this program again making the x as an instance variable, and then see whether it work or not. Yeah. So, compilation is successful, no error has been reported, and then this is the execution of the program. So, it basically call method I1 and method I2 from the program itself. As you see, method I1 can access the pi which is defined in the interface. Now, let us come back to the program again, and here we are in the process of creating the instance variable here. So, in int, yeah, int right. Now, so here int x equals to 100, as we know that this is basically, if we do not specify the keyword, that is basically public, what is called the public static will be default there. What about the int x declares of in area? So, this comment keep it here, no problem, this one, yeah. Now, let us see, yeah, that is what this basically creates an instance variable, basically run compile. Yeah. Now, here you can see int x without any initialization, it indicates that it is basically as an, it work as an instance variable. So, if we declare without any public static final keyword, it will automatically specify this one, but this is only applicable after the initialization. You should if it is a static variable, you should initialize this one. As there is no initialization, it treats as an instance variable, and no instance variable declaration is allowed in an interface method. So, this example explain that we cannot declare any instance variable, this one. Now, here, so we have learned about that a class can implement an interface. Now, it is interesting to note whether an interface can implement another interface or not. So, here is an example, as we see here, I1 is an interface declared with its own member I as 555 and its own public abstract method, namely print interface. And here is the second is I2 interface basically attempts to implement I1. In fact, all the entire code is invalid code, because interface I2 cannot implement other interface. Now, if we run this program, then it will report a compilation error. Yeah, as we see in the statement interface I2 implements I1, it basically is an error indicated here. So, instead of interface I2, if we write class I2 implements I1, it will work possibly. And another thing is that in the last statement print interface, if we made it okay, we have to make all the method that needs to be implemented as a public. Suppose if we declare as a default the print interface method in class I2, yes, just right public to remove, okay, fine. So, here, so it is default. Now, let us see, no default method implementation is allowed, or method implementation with any other access specifier is not allowed. As we see here in the void interface, it gives an error. So, we have to make it public there, then only it will be there. Now, a class can implement another interface. If a class implements any methods which is there in an interface, that method should be declared as a public, that we have learned it here. Okay. Right. So, we can run it, sir. Our next example, whether an interface implements an abstract class. As you know, an abstract class in many ways similar to interface, that abstract class also can have the abstract method, that means method without any code, and then it also can include a static variable. So, here you can see in this example a class C is an abstract class as we have declared, and here the static variable is declared as J, and it has one method print, but in case of abstract class we know it can include both abstract method as well as non abstract method. In this case, it is non abstract method. Now, if we attempt to implement interface this class C, that abstract class, by using implements, it is basically invalid. Now, if we run this, then you will see this program will not compilable, actually it will give the compilation error. Yeah. So, as we see, interface I2 implement C is basically it is not allowable to implement this one. Okay. So, no abstract class also can be implementable using any interface, but a class can be planned to implement this one. Now, one thing is that no method or any variable can be declared final in case of interface. It will leads to an error. Here is an example. Here we can see interface I1, which has one static variable public final, it is as I equals to 55, by default it is final. And now, the method here we can declare, you can see we have declared the method as a final and static. No, these two keywords are not applicable to any method declaration in an interface, only public and abstract is applicable. So, by default it is abstract. So, final static is not possible. So, this code will work only if we remove final and static from this one. Now, let us have the final static and run it. and one by one if we execute it we will see it. The next code basically class C implements I 1, it basically declare its own method public and then implement the print interface here. As we see there is an error. So, the error is say that modifier final not allowed here. Now, let us remove this modifier final and run it again, keep it static. Yeah. Okay. Now, run it again and let us see whether static keyword is not there. Here we can see it also reports an error missing method body or declare abstract. As we have declared the abstract, it is not taking this one. So, if we remove this static again, it will now final public, it is basically abstract we can write it or not write, now it will work. So, void printed we have to declare public. So, that is fine. So, declare the public in the class implementation, as we have not declared the public, all the implementation of the interface method should be declared as a public here. Okay. So, fine, now this program runs successfully. So, there is a mistake regarding the name of the class file. So, that is why it gives an error that it did not find the class file. Now, we have changed it. Yes. Okay, we are compiling. Yes, compilation is successful in this case, running this program. Yeah. Anyway, so our next illustration. Anyway, so the last illustration is not meant for any what is called the class there, only for the explanation that it will require just few properties to be satisfied. Anyway, so our next example which basically explain the single inheritance. Now, here let us have the look of the code interface I 1 with its public static final variable x and then its method 1, and this interface I 2 extends I 1. So, an interface can be extended from I 1, but cannot implements. Now, so extend means I 2 inherits I 1, and so as a process of inheritance, so it has its own members y and its own method which is also abstract, it is declared because it is an interface method. Now, class A 1 implements I 2. So, whenever I 2 come into this picture, so by virtue of inheritance all the method that is there I 1 method 1 also now inherited to I 2. So, here again see in this class A 1 implements I 2 method, as we see we declare one variable in its own. This is the class A 1 variable and it implements method 1 which is basically inherited from I 1 via I 2 and then also method 1 and method 2. And as we see here x and y are the two members which belongs to the interface I 1 and I 2, and by the process of implementation class A 1 has the readily accessible to these values x and y here. So, the main program looks like here we create an object of class A 1 and then we call the method 1 and method 2. So, if we call, so all the methods and then their variables those are there in the interface will be readily accessible to this one. So, let us have a quick execution of this program followed by the compilation. So, we can see yes, yeah, we can see that this program is now successfully executed and compilation there is no error there. Now, so this is the idea about single inheritance. Now, let us have the demonstration on multiple inheritance. Here again I 1 is an interface, as we declare one static variable I here and print one method in our interface I 2, the interface I2 is again there is again j as a static variable and print I2 methods are there. Now, multiple inheritance here, as we see class A implements I1 and I2. So, this is basically the idea about how multiply a class can inherit both from I1 and I2. In the last example, we see that I2 inherits I1, then class implements I2. Here basically class A can implements I1 and I2. Here I2 is not necessarily inherit from I1 basically. So, here is as the number of inheritance can be implemented by a single class. For example, class A implements I1, I2, I3 and so on. We can like this one. Now, in this class implementation, as we see, A value is the value of the class variable A, and then print 1 is an implementation of class interface I1, print I2 is an implementation of interface method I2, and finally, the print A is the class A methods which basically have the full access of the static variable, those are there in interfaces I and j namely. So, this is the program, as we can see the multiple inheritance. By the process of multiple inheritance, we can access all methods, those are there in interface, as well as all variables, those are there in the interfaces. Okay, as you see, this program runs successfully. Now, there is an alternative way of doing multiple inheritance. Our next demonstration is to explain this one. In the last example, as we see, class A1 implements I1 and I2. Now, both extends and implements can be added there. This is also one way of inheritance, multiple inheritance. In this example, as we see, class A is a class and interface I is an interface, and we see the class B extends class A, that means it inherits the super class A as well as implements I, it is also inherits basically the some variable as well as method. However, this implementation as its class B should implements I, the method print should be defined here in this class. As you have seen the public void, where is the print interface method? Yeah. So, as you see interface I, the print interface method is being implemented here, that print and then call it there. Okay. And class B basically okay. So, it implements the print interface method in interface, and then print B is basically its own constructor, who is basically called the class A constructor, that means super class constructor using the super keyword, and then also it called print interface method, because this constructor has the access of because of the implementation. And the main class is very simple here. The demonstration underscore 99 is the implementation of this, where we can create an object of class B, and then we can call the print B the method of the class B. Yeah. So, this is the one example. As we see, the multiple inheritance by means of extending, I mean inheriting a super class as well as implementing an interface. Now, there is another cases where it can extend one class and implements two or more interface at the same time. So, this example is here, class A is a class, interface C and D are the two interfaces, and you see is a multiple inheritance form where class B extends A, that means A is the super class B derived from A, as well as it implements C and D, that means class B also inherits from C and D. That means that all the static variable those are there in C and D, namely J and K is also accessible, as well as the variable which is protected in class A is also accessible. So, we can see this method that is there, or this class or main method we can say can access all the elements by means of this multiple inheritance. So, this is the one simple main method. As we see here, we create an object B, which is basically derived based on the multiple inheritance, and then call the method print B. Okay. So, this is a different way that we can see that how multiple inheritance is possible with the help of interface as well as class A. Now, what is the usage of this interface? We can do the multiple inheritance. This is the one application. Our next example basically explain that the usage of the interface. In fact, interface can helps to support the shared variable to use across the many packages or many classes in different packages. So, here is an example. As we see, the interface includes declaration of some variable. Go to the interface in package, my interface, go to the my interface. Yeah. So, we have declared one interface here. This interface includes some static variable which is declared here, no, yes, maybe this one. Now, so once this interface is declared and then stored in the package, then any other class can use them as a global variable look like. So, that means it is called the shared variable in that sense. Now, here is an example of one class which use basically interface, that means here class question implements all the shared constant, those are basically global variable you can say, and in this case is basically you see without any declaration it basically use return yes, return later, return soon, all these things. And here is a simple code, we can use the random function which is defined in java.util. It will basically generate a random number, and based on the random number generation it will print all these values depending on the random probabilities. Now, here this is another class which basically use the same things here, and we define another method called answer, and it basically take the results passed to it, and based on the result it will execute these codes are there. Now, let us have the quick method in this class. As we see, go to the next. Yeah. So, this method is basically create an object of question class which is declared, which use the interface or implements the interface, and then for this class we use the ask method. Ask method generate a random number, based on the random number it will print either yes, no, soon, never, maybe, or like this one. If we run this program, let us see what is the output it will give. It will give the output as it is a probabilistic one. So, different execution will not necessarily give the same output in this case. In this case we can see this is the output. If we run the same program again, we may see different output like this one. If we run again, it can give another output and so on. So, it is basically probabilistic program by means of generating random number, but it will discuss about how the shared variable can be used across the different classes. Now, we have to discuss in the what is the difference between interface object and then abstract class, interface type and then abstract class declaration. Now, we have let us have the one program here, and it is basically idea about the inheritance, and by means of inheritance we can create many objects there. And let us go to the main class. First discuss about the interface class here. Interface class, go to the interface class, interface, go to the interface. Yeah, fine. No, not this is interface, right? So, now this interface is defined in my package, in the package my interface. The name of the interface is GeoAnalyzer. As you see, this GeoAnalyzer interface has one static variable, namely pi, and then two public abstract method, area and perimeter. So, this method is basically the type, and now we want to create few classes which implements GeoAnalyzer, namely circle, ellipse and rectangle. So, this is the implementation of circle class which implements GeoAnalyzer. This is the implementation of ellipse class which is an implementation of GeoAnalyzer, and this is the implementation of rectangle class which is the implementation of GeoAnalyzer. It has its own this one and this. So, now you see the different class implements the GeoAnalyzer interface by the different methods actually in their own way. Circle has its own implementation, ellipse has its own implementation, rectangular has its own implementation. Once this implementation is done, now we can come to the main program which basically create the objects of this. Now, here we can see the demonstration 912 is the main class, and there is basically the method includes a display which basically take x and y, namely the area and perimeter of the geo objects. And here we can see we have created 3 objects, one object C of type class C, another object E of class ellipse, and another object R of class rectangle. Now, here geo analyzer, geo item the interface, and geo item is an object of interface we can just declare. So, we have declare, and then once it is declared we see it basically holds the class C, basically the upcasting C is equals to geo item. Now, if we do this, then we can call the display method which is defined in the main method by calling this geo item and dot area and geo item dot perimeter. Similarly, if the geo item holds the reference to ellipse object, then also same method can print it, but in this case this the display geo item area for the referencing of ellipse object call the method area which is declared in ellipse class, and then again if it reference to rectangle and then display area this one it also reference to the methods those are there in interface rectangle in the class rectangle. Now, here we can see the display method is basically binded polymorphism. The display method can display area perimeter for the different objects as per the reference is there. So, it is the great example of polymorphism by means of interface. Now, this program if we run it will work for us. Now, again repeat the same thing, but using the abstract class. So, in the previous case we have discussed about geo analyzer as an interface, we just want to do the same thing by means of abstract. Here is basically okay, this abstract class is declared in a package, let us have the package, it is there. Okay, so, this abstract class is declared here, go to the abstract class there, geometry. Yeah. So, here we can see public abstract class geometry, geometry is an abstract class here, and here we define 2 methods and abstract method. Abstract, as you know, the abstract method means no code is there, just look like a very similar to interface. Now, this basically example to illustrate the similarity and dissimilarity between interface and abstract it is there. Now, let us have the same way of class implementation, it is basically extends, because circle should extends geometry, here we can see circle. Now, the difference we can note, in the previous case circle implements geo analyzer, but here geometry being an abstract class we cannot implement, we just simply circle extends geometry. Likewise, ellipse extends geometry, and then rectangle extends geometry. As a process of extension is basically single inheritance, as you know. So, it basically inheritance, or you can say override the methods those are there in abstract method in case of geometry. So, these are the 3 implementation of 3 classes extending the geometry object, and finally, the main class here demonstration underscore 9.1 is 3. Yeah. So, this is the main class, as you see the main class here, it is more or less similar the previous example using interface. Geometry we create, we basically declare an array of what is called the objects of geo objects of type, here 3 array size is 3 here, array of abstract class we can say, just like interface objects we have created in case of interface, in case of abstract class also the object can be created as we see here. And then geo object 0 we create an instance of the class circle, and then it is basically assigned to the location 0, and similarly rectangle instance and ellipse instance are created, and we call the we pass the parameter to instantiate them properly. So, these are the instantiation and instantiation, but after the instantiation they are basically referred in the abstract class object like geo object in this case. And here again runtime polymorphism as we see in the next for loop. So, here total area geo objects I dot area. Now, for I equals to 0, so this dot area refer to circle objects. On the other hand, for I equals to 1, this area refer to the rectangle objects, and then for I equals to 2, this area refers to ellipse object. So, again it is an example of runtime polymorphism, because it is polymorphically resolved the different method depending on the objects it is there, although it looks like same for all calls actually, and if we run it the similar to the interface it will run and then give the execution. Okay, so, this is the right. So, this is the successful execution of the program. So, what we have learned about here, that more or less interface and abstract behaves in the same manner. Then why Java developer maintains both the thing? The difference only here is that abstract class, if you declare, it cannot be multiply inheritance. Whenever an inheritance interface if it is there, it can be multiply inheritance. So, this is the only difference between the abstract class and then interface, otherwise both the concepts are more or less same. So, we have learned about the interface, and if you have further any doubt, you are most welcome to post your queries, and all the programs those we have used in their demonstration, you are free to use it and then test it, so that you can practice it much more. So, thank you very much.